So yes, let's start our today's class. So hello everyone, this is lecture 10 on discrete mathematics, and in the previous lecture we have started advanced pigeonhole principle and I have given you the formula. So we have n pigeons and m pigeonhole. Condition is that n should be greater than m. Okay, if this is the case, then at least one pigeonhole will have n by m ceiling function pigeon. So n by m ceiling function or n minus 1 by m floor function plus 1, they are one and the same thing. Numerically they are equal. They in gate exam they can give any one of the formula. Okay, so we have started it and I have properly proven this formula, that why n by m ceiling function is correct, with the help of this example, and we have simply applied the common sense and nothing more than that. Okay, so the basic idea is we have to guarantee something. Okay, always true. The basic thing is we need always true kind of thing. Yes, so I hope this was clear to everyone, and now let's start our today's class. So the question is, how many minimum bicycles colored with 7 colors so as to guarantee that minimum 4 bicycles will have same color. So now see this, the word is guarantee. So you may say, sir, we need minimum bicycle and we want minimum four bicycles to have same color. So take 4 bicycles only. And there are 7 colors. So 7 colors are VIBGYOR, VIBGYOR. Okay, violet, indigo, blue, green, yellow, orange, red. So these are the 7 colors. So you will say, sir, take only 4 bicycles and you color them by same color. Yes, we can do that, but I have used the word guarantee. So in worst to worst case, I have to prove that thing. So if you take only 4 bicycles, then I can give, say, bicycle number 1 as violet, then indigo, then blue, and then green. So all will be different. That can be done. But I want to say that we have to guarantee minimum 4 bicycles should have same color. And what we want to ask, how many minimum bicycles are needed? Minimum how many bicycles are needed? So see this. So I will try to bifurcate it. Okay, so 4, 5, 6, 7. Then 8, obviously I have to repeat, 8, 9, 10, 11, 12, 13, 14, and then 15, 16, 17. Okay, I should not do it, I should say like this. So 14, then 21. Okay, and then 22. As soon as I take the 22 bicycle, it will have, so it will be guaranteed that at least 4 bicycles will have same color. I think you have got it. Okay, so this is very simple scenario. Okay, so I hope it's clear. Yes, if you have any doubt, then you can ask. Is it okay now? So minimum, how many bicycles are needed? So minimum 22 bicycles are needed. Okay. Yes. Minimum 22 bicycles are needed. Yes. So let me jump to the next slide now. Okay. And I have not applied any formula. I have not given you anything. The basic thing is, okay. Just a second. Please, just a second. Yeah, actually somebody came, that's why. Yes, so minimum 22 bicycles are needed. Okay, so we have done it, and I have not applied any formula. No need of formula. So just apply common sense. Okay, that is the basic way out. Now let me jump to the next slide.
No?
30. Yeah.
Can you read the question, please? How many minimum bicycles colored with
Ah,
surplus? What is that?
so as
All
to
right.
guarantee that minimum 4 bicycles will have same color.
Yes, sir. Yes.
So let me jump to the next slide. Yes, next is 30 persons in a party, and at least how many persons have birthday on the same day? That is the question. So it's again like that, only 30%. So we will consider the worst scenario. Okay, what is the worst scenario? So 7 days are there, 1, 2, 3, 4, 5, 6, 7, and 30 persons are there. So we will try to divide them. So person 1 up to person 7 are over, then person 14, then person 21. Okay, and then person 28. Okay, then 28, then 29, and then 30. So see this 4 and 1 5. So at least 5 will have birthday on the same day. That is guaranteed. And if you want to do, see, now you will get the sense of division. So 30 divided by 7, ceiling function. So 5 is the answer. Is it okay?
Yes, sir.
Okay, same month. What about same month? So 30 persons are there, 12 months are there, ceiling function, you will get the answer. 3 is the answer.
Awesome.
Okay, yes, take snapshot. I will jump to the next slide.
Done, sir.
Next is minimum how many cards should be picked from 52 cards. 52 cards mean the playing cards. Okay, the playing cards. Cards to guarantee at least 3 cards are of same suit. Okay, same suit. So we have 4 suit, na?
Yes.
Diamond, and then heart. Okay, and then we have spade. Okay, spade is like I do not know how to design that, but let me write it.
Yes, that's good.
Okay,
Yes.
so diamond, spade, and then we have heart. And what is the last one? We have total 4 now. Diamond, spade, heart, and okay, one more is there now. So total we have 4 suit. Okay, and 52 cards are there, and what we want to guarantee, at least 3 cards are of same suit. So this is very again very easy. So what we want, so say this is suit number 1, 2, 3, and 4. Okay, so 1, 2, 3, 4, 4 card pick. A worst case, all the 4 are of different, then 5, 6, 7, 8 different, and then the moment you pick the ninth one, you will get 3 card of same suit. So answer is 9. Okay. So by common sense we can do it. So nothing, so this is garbage data. 52 cards, this is a garbage data. Now please do not say sir 52 divided by 3 ceiling function or floor function. No, this is not the answer.
Yes.
Okay, so 9 cards should
But
be picked, and the
not
best way out
everywhere.
is, yes, please
Not
come
everywhere
again.
formula. Not everywhere the formula is essential.
Yeah. So you try to do by common sense. So we are picking the cards na. So we will pick first card, let us suppose that is of suit 1, then 2, then 3, then 4. So you just try to do that, and since we want a 3 color 3 cards of same suit, so minimum you can pick 3 also. But the moment you pick only 3 cards, then this is not guaranteed that they will be of same suit. Okay, they can be of different suit also. So you
Yes.
can say minimum 3 cards we want to take, but three all the 3 can be of different suit also. That is the biggest problem. No doubt chances are there that all the 3 are of same suit, but it is not guaranteed. We want guarantee here. So for guarantee we have to do like this.
The other suit is like club, no, sir.
Yes. Next last is club.
Yes, sir. That's
Okay, so let me jump to the next slide. So the basic idea, see how, where we will apply this common sense and all. As soon as you see the word at least 3 cards of same suit and so on, wherever you see at least, guarantee, that is the signal. that we have to apply pigeonhole principle. Okay. Yes, let me jump to the next slide now. Next is minimum how many cards should be picked from 52 cards to guarantee at least 3 cards are of same suit. Okay, same suit we have done, same type. We should do it same type. So same type. So how many types are there? So 13 types of cards
Same
are there.
type.
A, then 2, 3 up to 10, then J, Q and K. So total 13 are there. And we want at least 3 card of same type. So what should be done? So 1 to 13 is over, then here 26, and then what will we will get 39. Okay, now 30, sorry, we will not go till 39, only 27 is okay. Okay, so 1 to 13 all are different, then from 14 to 26 again all are different. The moment you pick the 27th card, you will say at least 3 will be of same type, that is for sure. Okay, so answer to this question is 27. Yes, any doubt? Okay, please take snapshot. I will jump to the next slide and see here again we have this thing, guarantee at least. So we will do this kind of thing, and it's simply common sense. Okay, yes. So I will jump to the next slide now. Okay, same kind we have done. I think this was copy pasted. Same kind again, copy paste. Minimum how many cards should be picked from the true card guarantee? At least 3 cards of same kind. Okay, done. I think same now. Okay, so yeah, let me verify if something is missing here.
Same, sir. Same suit, same kind you have written.
Mm-hmm. Yes, so same kind here and here.
Same.
Yeah, yes, same only. Okay, no, actually there is a small, I think, gap here. Minimum how many cards should be picked from 52 cards to guarantee at least 3 cards? Okay, this 30 cards are picked from 52 cards. Minimum how many cards of same kind? This is a different question now. So we have 30 cards are picked from 52 cards. Okay, so from 52 I am taken 30. The minimum how many are of same kind? So kind means A, then 1, then 2, then 3, dot dot dot, then 10, then J,
A,
Q and K. Okay, so
A,
total
A,
13 are there. So 1 to 13 are over, and then 26, and then 27, 28, 29, 38. It hardly matters. So only 3 will be of same kind. Yes, any doubt?
yeah, sir. A1, both has been written.
Okay, sorry. A. Yes, so finally 3 is the answer. 30
That's
cards are picked from 52 cards.
सर
Minimum
इसका
how many
4 आना
cards?
चाहिए ना
Why 4?
सो मतलब 127 और बीच बीच वाली लाइन जो भी होगी उसमें भी कार्ड्स आएंगे सर तो
So, no,
चार
no.
चार
Okay,
one.
let me tell you. See, 1 to 13 over. 13 cards are over
यस
here. Then
यस सर
14 to 26 are over here.
यस सर
So now 27, 28, 29, 30 till 39 you will take.
39 ओके ओके
And when 40th card will come, then you will say 4 card will be of same type. Na?
हाँ हाँ यस सर एटलीस्ट
Okay.
3 विल बी ऑफ सेम टाइम यस सर
That is for guarantee. That is the question. Na? With guarantee we have to say. So 3 is the answer. Okay.
यस सर यस
Okay, and previous one, let me see, minimum how many cards should be picked from 52 card to guarantee at least 3 cards of same kind. This is the same question only, no problem. Okay, please take snapshot. I will jump to the next slide now.
Done, sir.
Next is in every possible committee of 3 boy and 2 girl, from 10 boy and 5 girl is written on a chit of paper and put it in 4 hats. One of the hat will have at least how many chits? That is the question. So this is a little bit question of tougher side. So we see, actually The only thing is I have told you in gate exam 2 to 3 step question. 2 to 3 step. So just we have here one step extra. So what we are saying, in every possible committee of 3 boy and 2 girl from 10 boy and 5 girls. So we have 10 boy and 5 girls, and we are making committee of 3 boy and 2 girl. So first of all, make the committees. Now how many committees will be possible? Okay, how many committees will be possible? So committee will be from 10 you pick 3. Our work is not yet over because we have to pick girls also. So from 5 you pick 2. So 10C3 into 5C2, these are the total number of committees. Total committees. Total committee we have made it. So how many will be this? So 10 into 9 into 8 divided by 3 into 2. 5C2 is 10. We already know this thing. So 3 is a 9, 2 4 is a 8. So 1200. So 1200 total committees are possible. Now they are saying in every possible committee of this is written on a chit of paper. So 1200 chits you have made, and on each chit you have written the committee. Okay, so whatever, maybe the boy 1, boy 2, and so on, whatever committees you have made, total 1200 committees you have made, and each you have written on a chit of paper, and you have put them in 4 heads. So 1200 you can say chits you have made, and you are putting them in 4 heads. Now what they are saying, one of the head will have at least how many chits? So we want to guarantee that at least how many chits will be there. See, in the in worst case, what you can make all the 1200 chits, you can put it in one head. That is also possible. So but they are saying one of the head will have at least how many chits? At least. Okay, so directly indirectly we want to guarantee this thing. So obviously other will have 0. Okay, but this is not the even distribution. So what you can do? So 1200 you simply divide by 4.
300.
Yes, very good. 300. So I will say with guarantee that each head will have at least 300 chits. Are you getting it, na? So some of the head may have more than 300 also, but this is guaranteed that at least one of the head will have 300 chits. So please try to focus here. It is guaranteed. It is guaranteed that at least one head has 300 chits. This is guaranteed. Okay, so for example, if I take this scenario also, 1200 are given to 1 and rest 3 are having 0. No problem. Again, my statement is correct. It is guaranteed that at least one head has 300 chits. Other possibility can be you give 800 here, 400 here, and rest 2 zeros. Again, it is guaranteed that at least one head has 300 chits. 2 heads are having at least 200 chits now. Okay, no problem. So I am saying at least one head will have at least 300 chits. I hope I have made the point clear.
Yes, sir.
Okay, now please take snapshot. I will jump to the next slide. Done?
Sir.
Okay. So here by chance 400 was divisible by 4. If it was not divisible, then we will take ceiling function. Pigeonhole principle we have already studied that. Like if we have 1201 heads, then obviously I will guarantee at least one will have 301 heads. That is for sure. If we have 1201 heads, so 1201 divided by 4, so I will say at least one of the head will have 301 heads. Okay, because if I say, if I want to make the statement wrong that no one is having 301 heads, then how it will be possible? So obviously each and every will have 300 heads, at most 300 heads. So at most 300 heads in 4 heads I have at most 300 heads in every head. So 4 heads are there, so you can get only 1200 chits now, but we have 1201. So at least one will have at least 301 heads. Are you getting it? That's why I am applying ceiling function.
In spite
Yes.
of it being divided by 4, we apply ceiling function, sir.
Yeah. Okay. Let me tell you. No problem. See, if by chance I will say that 1201 chits are there, and we distribute them in 4 heads, then what you can say? At least one head will have at least one head will have at least dash jits. Yes, what should be your answer now? So you will say 1201 divided by 4. So you will get, now it is a confusing because 1201 is not divisible by 4. Okay, 1201 is not divisible by 4, so you have to take either ceiling or floor. So I, because number of chits are there na, I cannot take 0.2 chit, 0.1 chit, so number should be there. So I will say ceiling function, that means 301 will be my answer. So if you want to contradict my answer that 301 is not the answer, so you want to say directly indirectly that every head, by logic, you should apply logic here, every head has at most 300 jets. If you want to say this statement, every head has at most 300 jets, so you take 300 jets in every head, so you will be able to cover only 1200 jets only. What about the last jet? 1201 jet. So you have to apply that in one of the head, so immediately you will get 301 jets in one of the head. So that's
Yes.
why we are applying ceiling function. So this is what exactly pigeonhole principle is saying, or advanced pigeonhole principle is saying this thing only. So number divided by, so 1201 divided by 4, ceiling function. So you can imagine these are the pigeons and these are the pigeonholes. Okay, so at least one pigeonhole will have n upon m ceiling function pigeons. Is it okay now?
Yes, sir.
Yes,
Okay.
sir.
So take snapshot. I will jump to the next slide. Done. The next question, 1 to 10. These are numbers. Okay. Pick pair of distinct numbers. We want to pick pair of distinct numbers. Now, at least how many pairs will have same sum? This is a different kind of question. So what they want to say, we are picking pair of distinct number. We have 10 numbers, so we want to pick pair of distinct numbers. So pair means 2, so 10 C2. Distinct, na? Distinct means what? No repetition, combination with no repetition, 10 C2. So that is nothing but 10 into 9 divided by 2. So 45 pairs are there. 45 pairs exist. Now, at least how many pairs will have same sum? So how you will make the sum? See this, because we want to take distinct. So minimum possible sum will be what? 1 and 2 you have picked. So minimum possible sum is 3. And what is the maximum possible sum? You will take this biggest number 9 and 10. Repetition is not allowed. Please do not say sir 1 plus 1 2. No, I cannot take 1 2 times. I have to take only one time because clearly it is mentioned distinct numbers. So 1 plus 2 is 3 and biggest is 9 plus 10, that is 19. So sum is varying from 3 to 19. Okay, so sum can be the 3, then 4, then 5 and so on up to 19. Are you getting it? 3, 4, 5 up to 19. So again same question, how many numbers are there from 3 to 19? So 19 minus 3 plus 1. Upper bound minus lower bound plus 1. If you have any confusion, I have told you many times, take small 1, 2, 3. So how many numbers are from 1 to 3? You just count 1, 2 and 3. 3 numbers are there. So how you have got 3? 3 minus 1 plus 1. Upper bound minus lower bound plus 1. So 19 minus 3 plus 1. So how many numbers are there? So these will be 17. Yes, so 17 numbers are there. So 17 different sum is possible. And now I think you have got it. So 17 is nothing but your pigeonholes. And 45 is nothing but your pigeons. So what will be your answer? 45 divided by 17, ceiling function. So it will be 3. Okay, and I have done by pigeonhole principle. You can do by common sense also. 17 different kind of sum is possible. So you can write like this. Sum is 3, 4, 5 dot 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 up to 19. Okay, so you will say you have picked the pairs now. So first pair 1, pair 2 dot 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 up to pair 17, because 3 to 19, 17 is there. So 17 you have exhausted. Now 17 into 2, 34. So dot 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 P34, pair 34 you have taken. So now next pair number 35, 36, I think you have got it. So we will go till 45, whatever may will be the 45, because 17 into 3 is what? It will be 51. So
51.
pair 51, yeah. So 45 is less than that. So obviously it will be guaranteed that 3 pairs will have same sum. At least 3 pairs will have same sum. This is guaranteed. Okay, is it okay?
Yes, sir.
Okay, please take snapshot. I will jump to the next slide.
Done,
Epic
sir.
now. Okay, so what if the previous question only I have just said pair can have repeated numbers. Okay, repetition is allowed. So repetition is allowed. So now 1, 2, 3 up to 10. So if repetition is allowed, then how many pairs we can take? First of all, we have to answer this question. How many pairs?
19.
No,
19 pairs.
repetition is allowed. Na? So see, if repetition was not allowed, then we have 45. So if we
Okay,
allow
okay, sir.
repetition, then number will be more than 45. Na? It cannot be less than
Yes, sir, yes.
45.
100, I think so.
How
100
100?
pairs. Sir, first value can have 10 possibility, second value can have 10 possibility.
Okay, so here you can take from 1 to 10, and here also you can take from 1 to 10, like this. But here the biggest problem will be you will take 3, 2 and 2, 3 different.
Okay, sir. Order.
Order does not matter na, because I'm just picking the pairs. Order does not
Yes, yes.
matter. So clearly this is what? Combination with unlimited repetition. Combination with unlimited repetition. Because you can take 1 2 times also, you can take 2 2 times also, and so on. Combination with unlimited repetition. So combination with unlimited repetition, formula was n minus 1 plus RCR. I think if you remember this chocolate problem and all, this is that only.
Yes.
So now how we will write? We will take see, numbers are from 1 to 10 na? So you can take x1 is the number of ones which you have taken, x2 is the number of 2 which you have taken, dot x10 number of 10 which you have taken, and their sum should be equal to 2 because you just want to be 2 numbers only. So n is what? Number of variables. 10 minus 1 plus r is what? 2. C, r is what? 2. So it comes out to be 11 C2. 11 C2 is nothing but 11 into 10 by 2. 55 is the answer. Yeah. Is any doubt?
Clear, sir.
Okay, and if you want to do by common sense, then you can do that also. But no doubt you may find this method to be little bit difficult now because you have not done a lot of practice. But once you will do a lot of practice, you will immediately say, okay, sir, this is the best method. But by common sense, if you want, then I can tell you that also. See, if without repetition I was taking, answer was very simple because there was no repetition. NCR, that is 10 C2, that was 45. Now, if we allow repetition, then how many pairs will be there? Only 1, 1, 2, 2, up to 10, 10. So only 10 extra pairs have been added. So 45 plus 10, that is 55. Same answer we have got it. So this is another way, but this is not guaranteed. No doubt you will say, sir, this is the best method which you have told us now, but I will suggest do not follow such kind of thing. This is purely popcorn thinking. In GATE exam, it is not necessary that your mind will work and you will be able to guess such kind of thing in GATE exam. This is the best. This is the best. Immediately you will say, okay, pairs can be repeated. So unlimited repetition, simply apply the formula and get the answer. No need to go here and there and no need to do any kind of other things. The more you practice, the more you get. This is the best way. Okay, but no, there is no guarantee that you will be able to guess this kind of thing in GATE exam. This is not guaranteed.
सर इस
Yeah.
प्रॉब्लम को हम मॉडल डाउन कर सकते हैं क्या कि 10 different boxes and how many ways we can put 2 balls in 10 different boxes?
Yes. Same. That is only combination with unlimited repetition, na? Which we have studied previously. I have taken this thing only, na? You
Yes,
can
sir.
take the 10 different chocolates and you want to
Yes.
pick only 2 chocolates. How many ways?
Okay.
Okay, same thing. Same. We have done like this only. Okay. So the final answer is 55. So pairs we have got it. Okay. And sum. Now comes the sum. How many different sum will be possible? So now you can take 1 plus 1, minimum 2. And maximum will be, you can take now 10 plus 10, that is 20. So how many are there? 20 minus 2 plus 1, 19.
Yes.
So 19 different sums are possible. So final answer will be very simple, 955 upon 19 ceiling function. Again answer is 3. By chance answer 3 is coming. So if repetition is allowed or repetition not allowed, 3 same answer is coming by chance.
Yes, sir.
Please take snapshot. I will jump to the next slide.
Done, sir.
Let me do. So now we are saying 10 pair of red socks we are having, 15 pair of green socks we are having, 12 pair of blue socks we are having in a laundry basket. So we have a laundry basket, and in that we have you can say pairs of socks, different pair of socks, and obviously all of them are mingled up. You cannot say that the 10 pairs are different, 15 pairs are different. You have just put them in laundry basket. So by common sense you will say everything is mingled up. Now they want to say minimum number of socks drawn to guarantee that we get a matching pair. That is very beautiful question. So see this, guarantee minimum. So you will apply pigeonhole principle. By common sense we will try to do it. So see, if you are lucky person, minimum number of socks drawn to guarantee that we get a matching pair. So if you are lucky person, you will say we will simply put our hand in the basket, you just pick the two socks and they are the matching pair only. Are you getting it? So that is the simplest case. But we will say because we want to guarantee na, so you will consider yourself as the most unlucky person on this earth. Consider yourself as most unlucky person on this earth. So what you will do? So see this. Now 10 pairs of red socks. So you will pick 10 socks, and each of them will be from the different you can say pair. Are you getting it? So see, and I have said 10 pairs of red socks. So obviously all of them are different. I have not used the word identical. Please try to focus here. I have not used the word identical. So red socks means on one pair you have drawing like this. On another pair you are drawing like this. Another pair you are drawing like this, and so on. That directly and directly all the pairs are different. So now I am saying you pick the 10 socks, and by chance all the 10 socks are different from the different pairs. Now next you pick the next 15 and all of them are different. Now you pick the 12, all of them are different. And now the moment you pick the next socks, it will be guaranteed that this socks will make pair with this, so with this or with this. That is guaranteed. So my final answer will be what? 25, 35, that is 38. 38 is the answer.
Sir, if it was identical, then
If it was identical, then the problem will be a different kind of thing. Then what we will say, so we have 10 pair of identical red socks now. So
yes.
now, so I will take only one socks from here. Okay. So because the moment I pick the second, so yeah, so now actually then it will be a different kind of question. We have to answer whether it is left your left left feet or right feet.
Yes, sir.
Okay, so now they have to mention this thing also, whether left feet or right feet are different or they are same. If they are same, then I will say you just pick one from here. One next socks which you picked was this, and next socks which you picked was this, and the moment you pick the next socks, that means 4 socks will be our answer.
Yes.
And sir, left right वाला होता तो 28 होता.
हाँ, तो फिर हम क्या कहते हैं? Then what we will say? We will say you just consider yourself as the most unlucky person. So you just you take 10 from here. Why 10 from here? Because all are left. So you are picking left, left, left. So here also you are picking all left, 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 and here also you are picking all left, left, left. And the moment you pick the next socks, obviously all will be right one which are left. So plus 1 will be your answer. So same answer will be there. Okay, if they are identical but left, right are different, and if left, right are same, then only 4 is the answer. So it's all about sense. I am not giving you any formula. I am not giving you anything. Just consider yourself as the most unlucky person on this earth, and you try to pick the socks. That is the basic way. Okay.
Yes, sir.
Yes. So please take snapshot. I will jump to the next slide. So next is generating functions. Okay. So yes. And what if Yeah, and there are two more questions left. One pair of matching red socks if I want, then what will be your answer? If I want one pair of matching red socks, so what I will say? I will say first I will pick 10 socks and all are different. All are from different pairs. Red we have taken. Then I will say, since I am most unlucky person, so I will say you take all the 15 pairs of green socks. So next you pick and you keep on picking. So you pick the 30 socks and all green pair socks are exhausted. Then all blue pair are exhausted. And now you pick one more socks, then it will be guaranteed that it will be one of the red pair will be matching. So what will be our answer? 30 plus 24 plus 10 and then plus 1. So 40, 65 is the answer. Yes, any doubt here?
65. I answered this.
Okay, okay. So next is this one pair of matching green socks you want. So what you will say? Pick the all 15 green. You just pick them, and all are from different pairs. Then you pick all the 10 pairs of your red socks, and then you pick all the 12 pair of your blue socks. Then what will be your answer? The plus one. Plus one will be your answer. Okay. So 24, then 20, 44, 54, 59, and then 60. 60 is the answer. Is it okay now?
Yes, sir.
Okay. So now take snapshot. I will jump to the next slide.
Done, sir.
Okay. So now our pigeonhole principle is over. So finally, we have concluded all the 9 categories of problems. 9 categories of problem we have done. So 6 categories were of permutation and combination. 7th category was distribution problem. 8th category was principle of inclusion exclusion, and the 9th category was pigeonhole principle. And with each category I have told you what are the keywords and all. So you in GATE exam you just have to identify the category, apply the formula and get the answer. That is very simple thing. Okay. So now we will jump to the next chapter of combinatorics, that is the your summation part, and the first topic is generating functions. So let me start that. Let me jump to the next slide. So now we are going to start generating functions. So what is exactly generating function? Don't worry, I will come back to it, but let me first make the background. So what is the background here? So first is you should know what is a numeric function. Numeric function is nothing but a normal function from whole number to real number. What is a function? Function means mapping only. Okay. So from whole numbers to real number we are doing mapping. Whole number start from 0 na? Natural number start from 1, whole number start from 0. So from whole number to real number we will do mapping. That is numeric function. For example, fx can be x. Okay, so fx x means what? See this. You have 0, 1, 2, 3 dot 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 up to infinity. This is your whole number and this is your real number set. So I think you know now, this is domain and this is codomain. Real number is the codomain.
Yes, sir.
And anyway we will study that in set theory also. So this is the real number set. So here you will be having some negative real numbers, and then say we have got 0, and then we have got 1. Between 0 and 1 we have infinite real numbers, and then we have 2, and then we have 3 dot 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 like this. So fx is equal to x means what? So when 0 is mapped to 0, 1 is mapped to 1, 2 is mapped to 2, 3 is mapped to 3, and so on. Okay. So what is the range? Range means the these numbers, okay, which are mapped. So subset of codomain. Okay. So range will be whole numbers only. Yes. So range of this function will be whole numbers. Range will be W. Domain is W, and codomain is real number. For this x, fx is equal to x. Similarly, you can consider fx is equal to x plus 1, one and the same thing. fx is equal to root x. This is also your domain is whole number and codomain is real number. So I think you have got it. This is a function. X square also, that is also good. Then x plus 0.5, this is also good, and so on. So we can take many functions like this. So all these examples are of numeric function. So what are numeric function? Where domain is whole number and codomain is real number. Domain is whole number and codomain is real number. That is numeric function. Okay. So I think you have got it. If anybody is having any doubt, please let me know. These are very basic things. Is it okay?
Understood. Yes.
Got it, sir.
Okay, so let me jump to the next slide. So this is all about numeric function. Now see the representation. Numeric function is represented as AR. This is the representation, AR, like this. So for example, if I say fx is equal to x, this will be represented as AR is equal to r. RR. Fx is equal to x square, you will say AR is equal to r square. R and r square. So you just simply note down this thing. Fx is nothing but your type AR type. So just representation, that's it. Okay, fx is equal to root x, so what you will say, AR is equal to root r. Fx is equal to x square plus 1, AR is equal to r square plus 1. So simple. So it's just a representation. We will use all these representation as generating functions, so try to understand them. Done?
Yes, sir.
Okay, so let me jump to the next slide. Yes, so what we can say now, say fx is equal to x, so corresponding numeric function will be AR is equal to r. I have told you. So what we say, f0 is 0. So that means when input is 0, output is 0. Okay, f1 is 1. So when input is 1, output is 1 for the function. I think you have got it. Na? f2 is 2. So when input is 2, output is 2. f3 is 3, like this. Because fx is x only. Like this we will write. So in case of numeric function, how we will write this is the by the way normal function representation. But when we will represent it in numeric function type, we will say a0 is 0, a1 is 1, a2 is 2, a3 is 3, 3 3, 2 2, 1 1, 0 0. Because AR is R. I think it's very obvious now.
Yes.
Yes,
Yes, sir.
another function. Okay, so another function is fx is equal to x plus 1. So f of 0 will be what? 1. When input is 0, output is 1. X, then x plus 1. Input is 1, output is 2. 2, 3, 3, 4, like this. So how you will write it in numeric function format? AR is R plus 1, A0 is 1, A1 is 2, A2 is 3, A3 is 4, dot dot dot. Okay?
Yes, sir.
Okay, so take snapshot. I will jump to the next slide.
Done, sir.
Okay. So now says fx is equal to x. If this is a function, so whole number is from 0, 1, 2, 3 up to infinity. Domain is whole number, and codomain is real numbers. So we have taken just 0, 1, 2, and so on. So range is this, na? Range is 0, 1, 2, 3 up to infinity. That is the whole number only. Range is this whole number only. Okay. So now since I have told you, see this. See from the previous slide, a0 is a0 is 0, a1 is 1, and so on. So I will say like this: a0 is 0, a1 is 1, a2 is 2, a3 is 3. Okay, so we call this as a sequence. So sequence is what? Range of the numeric function. And here obviously order matters. So wherever order matters, we will write that in circular bracket. Where order does not matter, we write in the set format, that is curly brackets. So here obviously order matter, na? Because if you change 2 here and then 3 here, then a2 will become 3 and a3 will become 2. That is obviously wrong. So here order matter. So sequence is what? Sequence is your simply range of the numeric function. And here order matters. Okay.
Yes, sir.
Yes. So we have introduced a new term, that is sequence. So sequence is range of numeric function. Take snapshot. I will jump to the next slide. Okay. Okay. So now we are mature enough. We can start the generating function. So what is generating function? For every numeric function. What is a numeric function? Please try to toss everything in your mind. It is normal function only from whole number to real number. That's it. So for every numeric function, we have a generating function. So we will say if numeric function is AR, I have told you representation of numeric function is AR, then its corresponding generating function is represented as AX, and it will be sigma R is equal to 0 to infinity AR multiplied by X power R. So if you this is known as closed form of generating function. If you simply open it up, you will say when R is 0, it will be A0 multiplied by X power 0, then A1 multiplied by X power 1, then A2 multiplied by X power 2, and so on up to infinity. This is known as open form of generating function. Are you getting it? So simple, it's very simple. You just try to remember this thing. If numeric function is AR, then its corresponding generating function AX is represented as sigma R is equal to 0 to infinity AR into X power R. That's it. Okay, so if you open it up, you will get an open form. If you leave like this, it is a closed form.
Yes, sir.
Okay, so if numeric function is AR, then corresponding generative function is AR into X power R, and sigma R is equal to 0 to infinity. So this is the keyword. Whenever in GATE exam you see sigma R is equal to 0 to infinity, or you say infinite sum kind of thing you see, immediately you will say this is a question of generating function. Immediately you will say question is of generating function. So this is the way to check in GATE exam. Okay, please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So now what is the application of generating function? I have told you for every numeric function AR we have a generating function like this. So why we are studying it? Application. Combination with limited repetition we have told you in the previous class, and only one application is there in your GATE syllabus. Actually, if I told you more precisely, generating function is a tool to solve very complex counting problems. Okay, if you take combinatorics and all in your you can say in your MTech in IITs, then you will study all these things in more detail. But it's not in our syllabus, so we will not study more deeply or more applications of generating function. So only one application is there in your GATE syllabus, that is combination with limited repetition. I have told you that with generating functions. Okay, and actually generating function is also known as discrete calculus. So for you already know integration, differentiation, lots and lots of application in everywhere, in physics, in chemistry, everywhere you have seen it. So same is the scenario here. So it is integration differentiation, that is continuous calculus, but it is a discrete calculus. We are studying discrete mathematics, na? That's why discrete calculus. Discrete means everything you can see. I have told you in logic also. Discrete means this is a table, and here we have put some apples. So discrete means you are able to see what is first number, second number, and so on. There is sufficient gap. Okay, continuous means just like water, real number, real number. Okay, that is continuous. Okay, so in integration, obviously we are using real numbers and all. Na? So that's why it is continuous calculus. But generating function is known as discrete calculus, and it has lots and lots of applications. And where it is used in complex counting problems. Okay. And anyway, since it is a discrete calculus and continuous thing is obviously difficult to handle, like real number is very difficult to handle, but natural numbers and all we can handle them easily. So obviously generating function, you can consider generating function is just like your integration. Why? Because in integration also we are doing some continuous sum. Continuous sum is integration, and generating function is discrete sum, because I have applied 0 to infinity, sigma r is equal to 0 to infinity AR X power R. So I am doing summation only. Okay. So generating function is your discrete sum, but integration is continuous sum. So you can consider generating function as like integration only. But in integration we have hell lots of rules and regulations. Product rule, okay, and then partial fraction we can do, like a by b function is there, then we will do partial fraction and all. We have done lots and lots of rules and regulations, but here we have very less rules and regulations. And formulas will be like that only. Like in integration, you already know sin x integration is minus cos x is sin x, and so on. So like that we will study some formulas, and you will simply apply those formula in GATE exam to get your answer. Okay, that is the basic rule and regulation or working rule for generating function. So we will keep on in this topic generating function. We will keep on developing formulas and formulas, and by if you remember all those formulas, you will be able to answer gate question very easily. Okay, and anyway, we will solve lots and lots of questions. You will get clarity. Okay, same like integration. If you do not know cos x integration is sin x, then obviously you cannot solve integration question. Same is the scenario here. So we have some basic formulas. If you remember those formulas, you will be able to answer generating function question very easily. Otherwise, obviously you won't be able to answer them. So you can consider them as integration only. Generating function is just like integration only. Okay, and in integration we keep on see we use substitution like this. We have cos t square dt, so we will replace t square by something and all, then we will be able to solve na. So for everything we do not have formula, so we try to you can say if we have any question of integration, you try to build that in the form of formula, and the moment you apply the formula you will get the answer. So you simply keep on changing the form of the question. Same will be here. So whatever question we are having, we will try to mold it in such a way that we are able to apply the formula and get the answer. Same working rule, just like integration. Okay. Yes, so let me jump to the next slide. Please take snapshot.
Done, sir.
Yes, sir.
Okay. So generating function, I have told it is very simple. It is not complex as integration, because in integration we have multiplication, product rule, and so on. We will not do these things. Okay. So in generating function we will do simply addition, subtraction. That's it. But in integration we are doing addition, subtraction, multiplication, division, everything we are doing. But here we will do only addition, subtraction. That's why it is very simple. Okay. Let me jump to the next slide. So now we will start now. Okay, so now try to focus. AR is 1. Very basic formulas we are going to derive. So very basic thing is AR is equal to 1. Now we want to find the generating function. AR is 1 means what? Numeric function is 1. So directly what you want to say, fx is equal to 1 only. If you want me to show, I will say like this. Since it is a numeric function, so from whole number to real number 0, 1, 2, 3 dot up to infinity, and real numbers are say here 0 and here 1, here 2 dot up to infinity. Okay, so what we are saying, fx is equal to 1, so that means every number is going to 1 only. Mapping is like this, dot every number is mapped to 1 only. That is the basic thing. Okay, so numeric function AR is equal to 1 means directly x is equal to 1 only. Okay, yes, and now for this numeric function I want to derive the generating function. Okay, please be familiar with all these things, otherwise you will get confused. Okay, so we should not confuse here. And if you want me to show you sequence, please tell me the sequence. Sequence was what? Range of the range is only 1 na? So how we will write? 1 comma 1 comma 1 comma 1 up to infinity. Why? Because a0 is also 1, a1 is 1, a2 is 1 dot. Are you getting it? A0 means what? F of 0. F of 0 is 1, F of 1 is 1, F of 2 is 1, F of 3 is 1, everything is 1. So that's why I will write 1 up to infinity. Okay. So they can ask question anyway, whatever way they want. They will simply say numeric function AR is equal to 1, find the generating function, or they will say this is a sequence, find the generating function. Are you getting it? So anyway, we will tell you lots and lots of ways how questions can be designed. Don't worry about it. It was the basic introduction. Yes. Please let me know if anybody is having any doubt.
Clear, sir.
Okay. Okay now. So how we will solve it, let me give you the idea. See this. Let me jump to the next slide. Okay, so in the next slide we do not have space, so let me do it here itself. Okay. So what we will do, see, I will say what is generating function? Corresponding to every numeric function we have a generating function, and generating function is represented by ax, and what was the formula? Sigma r is equal to 0 to infinity ar multiplied by x power r. What is this ar? This ar is your numeric function. Are you getting it? See this. If you have doubt, I have told you clearly. Definition was this only. What numeric function is ar? Then corresponding to numeric function, generating function was r is equal to 0 to infinity ar into x power r. So I have simply written that. I have not done anything extra. So generating function is represented by ax. Sigma r is equal to 0 to infinity ar into x power r. Closed form I have written. What is ar? Ar is 1. So simply apply it. R is equal to 0 to infinity x power r. Now we do not know what is x here. So x is any number, but the condition is that it should be greater than 0 and less than 1. So it is between 0 and 1. So now if you open it up, what you will get? X power 0. When r is 0, x power 0. Then plus x power 1 plus x power 2 plus x power 3 dot 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 up to infinity. Yes, are you getting it? So now what is this? This is GP only. This is GP. So and x is from 0 to 1. So I think you already know what is the formula of GP? A into 1 minus r power n upon 1 minus r. Now n is going to infinity and r common ratio is x only. Please let me know if you have any confusion here. Sum of n
So,
terms of GP is this. Yeah.
so this condition x is between 0 and 1, it will be given in the question.
No, it is by default. Otherwise, obviously, if it is not the case, then its sum will be infinity only. And we are doing counting problems. So counting problems, sum should be some number, na? If infinity is not a number, so that is by default and that is obvious. We have to take it. Even if they do not give, you have to take it. Otherwise, it's obvious. Sum will be infinity. If x is any number greater than 1, sum will be infinity, na?
Yes, sir.
So that's why.
Okay.
So even if they do not give, you have to take it. By default, we have to take it. Okay. So now see this sum of n terms of GP is a into 1 minus r power n upon 1 minus r. Okay. R is the common ratio. I think you already know. What is A? A is the first term. First term is what? X power 0 is 1 only. So 1 multiplied by 1 minus r power infinity, because infinity terms are there, upon 1 minus r. So what is r power infinity? So r is a number between 0 and 1. So if you take number to be 0.5, so 0.5 power 2 is what? 0.5 power 1 is 0.5, 0.5 power 2 is 0.25, 0.5 power 3 is 0.125. Are you getting it? The power is increasing, then this number is decreasing. See, first of all, we are having 0.5, then we are having 0.25, then we are having 0.125, and so on. As the power increases, this number is decreasing. So obviously, when we will go till infinity, it will become 0. R power infinity will become 0. So when r power infinity will become 0, so what will be our answer? 1 into 1 minus 0 is nothing but 1 only. So 1 upon 1 minus r. R is what? R is common ratio, that is x only. So this is my answer. So finally, what we will get? Our answer will be 1 upon 1 minus x. So if numeric function AR is 1, then corresponding generating function AX will be 1 upon 1 minus x. This is my answer. Yes, please let me know if anybody is having any doubt.
Yes, sir.
Clear? Okay.
Yes.
Now, okay. Take snapshot. I will jump to the next slide.
Answer.
Okay. So next is if now this type of question will be asked in GATE. So try to focus. If numeric function is 1, they will simply say like this. So indirectly you will say, okay, AR is equal to 1. What is the generating function? Simply you will answer 1 upon 1 minus x. They can say like this also, 1, 1, 1 up to infinity. What is the generating function for the sequence? This is a sequence. What is the generating function for the sequence? You will say 1 upon 1 minus x. They can say like this also, r is equal to 0 to infinity x power r. What is the sum? Sum is 1 upon 1 minus x. All the three questions are same only. Please try to focus. If you have any doubt, see this. Generating function I have told you. I have expanded this only. And I have got answer 1 upon 1 minus x. Any doubt?
Nice.
No, sir.
Okay. So now next question. Question number 2. So slowly we will build the things. So our first question is over. And we have got if numeric function is 1, generating function is 1 upon 1 minus x. So now please tell me if numeric function is 5, what will be the generating function? So first of all, please write the sequence. Sequence will be what? 5, 5, 5, 5 up to infinity. That means what? A0 is 5, A1 is 5, A2 is 5, A3 is 5, everything is 5 now. Are you getting it? A0 is 5, A1 is 5, A2 is 5, A3 is 5, dot dot dot. So sequence will be 555. Like the sequence was 111, now sequence will be 555. So what is the generating function? Simply apply the formula. What is the generating function? Generating function is represented by AX. AX is what? Sigma R is equal to 0 to infinity AR multiplied by X power R. So R is equal to 0 to infinity. AR is what? AR is what? 5. 5 multiplied by X power R. So now I think you already know 5 is a constant quantity. So you can take 5 outside also. So 5 multiplied by R is equal to 0 to infinity X power R. And I have told you just now what was the value? 1 upon 1 minus X. So finally what we will get? 5 into 1 upon 1 minus X. And that is nothing but 5 upon 1 minus X. So simple. So are you getting
Yes,
it? How we are building the concepts. So
Yes,
everywhere this linking will be done. So first is this. The very basic formula was this. From this I have read this very very fastly. Okay. So now let me jump to the next slide. Done.
Yes, sir.
So next is 333 up to infinity. What is the generating function? So what they have given
That
you
is
the sequence.
3 by 1 by 3 by
Yes,
1
yes,
by.
very good, very good. So numeric function, step number 1. You will write the numeric function. Numeric function is AR is 3. So what will be the generating function? Step number 2. I think you have got it. 3 upon 1 minus X. Yes. Should I derive it or you have got it, na?
We understood it, sir.
got it, sir. Got it.
Okay, okay, okay. So now let me jump to the next slide, and now I will show you a very beautiful property. Let me jump to the next slide. Okay, and let me first generalize here. K up to infinity. So this is a sequence. Generating function will be K upon 1 minus X. Okay. Yes. So
Sir.
now, yeah. So now property is coming. See the next slide now. Okay, generalized. Oh, I have done it here itself. So generalized answer is K upon 1 minus X. We have done it. Now see the property. What is the property of the generating function? If numeric function is AR, corresponding generating function was AX. So if numeric function is multiplied by K, then corresponding generating function is also multiplied by K. See this. For example, AR was 1. Generating function was 1 upon 1 minus X. So when if numeric function is 5, 5 is nothing but 5 multiplied by 1. So it will be 5 multiplied by 1 upon 1 minus X. So that is the beauty of this property. So for AR we have AX, then for K multiplied by AR it will be K multiplied by AX. Okay, we will use this property many times. Done?
Yes, sir.
Okay, let me jump to the next slide. So in GATE exam, they will ask each and every possible way. You should know each and everything. So for example, they can give generating function is 1 upon 1 minus X. What is the numeric function? Immediately you will say, sir, 1. They will say numeric, if generating function is 5 upon 1 minus X, immediately you will say numeric function is 5. Like this. Okay, so you should be able to answer a straight question, opposite question, everything you should know. Now let me say they can ask like this also. If generating function is this, what will be the A20? So for that you will say first of all AR. Numeric function AR is 1. So R you can put any value, answer will be 1 only. So you can put R 0, 1, 2, 3, any value. So 20, no problem, answer is 1. Another way they can ask question is AX is this 1 upon 1 minus X. They will say in powers.
That 320.
Okay, no problem. So see, AR is 1. So what do you mean by AR is 1? You will say A0 is 1, A1 is 1,
Yes,
A2
sir.
is 1, A3 is 1, and so on. And what exactly are these? Try to toss everything in your mind. Only then you will get clarity. F0 is 1. What is A1? A1 is a representation. F1 is 1. This means like this. A2 is representation. F of 2 is 1. So directly and indirectly they are saying simply function fx was 1 only.
Yes, sir.
Okay. So now see this, what they are saying, ax is 1 upon 1 minus x in power series expansion, coefficient of x power 20 they are asking. So in power series expansion, say so they will use these heavy words just to confuse you. So what is exactly this thing? Ax is 1 upon 1 minus x. So sigma r is equal to 0 to infinity. X power r is 1 upon 1 minus x. Ax is generating this like this only, na? Are you getting it?
Yes, sir.
So more precisely, if you want me to do step by step, then I will say okay, generating function is ar into x power r. Let me write it properly. Ar into x power r. Okay, and now this is 1 upon 1 minus x. So clearly you will get the idea. Okay, ar is nothing but your 1 only. Okay, so now if you expand it, that is your power series expansion. So what will be your answer? A0 into x power 0 plus, because of sigma means sum, a1 into x power 1 plus a2 into x power 2 plus a3 into x power 3 dot. So they are asking coefficient of x power 20. So what do you mean by this? A20 into x power 20. So they are asking coefficient of x power 20, that is nothing but A20 only. What is A20? A20 you already know, 1.
1.
That is your answer. Okay.
Yes, sir.
Okay, now take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is generating function is 10 upon 1 minus x. Now they are asking these 4 questions. Sequence. Sequence will be what?
10, 10, 10, 10.
Yes, very good. 10, 10, 10, 10 dot up to infinity like this. What is AR?
10.
1.
10,
10,
10, 10. This
10 times,
because
sir.
of
Yes,
this.
yes, sir.
A20,
10.
10. Coefficient of x power 20,
This also 10.
10,
10.
sir.
Yes, that's it. So these are the type of question which they will ask. So now why you are able to answer this question? Why these are very easy?
Because you
Because
made
you
a
know 1 upon 1 minus x. Yeah, obviously I made it. But 1 upon 1 minus x is 1. You know this thing. So I should say like this. Generating function is 1 upon 1 minus x. Then corresponding numeric function AR is 1. You know this thing. Only then you are able to answer this question. Otherwise, you won't be able to answer such question. You will say, what is this? You will get confused.
Yes, sir.
Okay. So that's why I was saying, just like integration. You already know integration of cos x is sin x. Only then you will be able to answer simple questions very easily. Okay, that is the basic thing. So now let me jump to the next slide. Okay. Next is generating function is 1 upon 1 plus x. What is the numeric function? So now we will have to solve this. I have told you 1 upon 1 minus x.
Minus.
Then our numeric function was 1. But now minus x is changed to plus x. So what we should do now? So how to approach such kind of question? Let me develop the basic idea. Okay, how we will solve it? Let me develop the basic idea. So what I will say, generating function definition. I will simply apply the definition. What is the definition of generating function? Sigma r is equal to 0 to infinity ar into x power r. That is given as what? Generating function is given as 1 upon 1 plus x. So I will write 1 upon 1 plus x. Are you getting it? So
Yes,
now if I say AR is 1, okay, if we say AR is 1, then answer was 1 upon 1 minus x, but we want answer to be 1 plus x. That is the biggest confusion which we are having right now. Are you getting it? If AR is 1, answer is 1 upon 1 minus x, but here I am having 1 plus x. So let me twist it. I will say like this. Sigma r is equal to 0 to infinity x power r, that is equal to 1 upon 1 minus x. Are you getting it? I have just solved it. Na? AR is 1. When numeric function is 1, we have got this thing. And if you are not able to remember, just toss in your mind x power r. Sigma r is equal to 0 to infinity x power r. It is nothing but your GP only. GP. So sum of GP, sum of infinite terms of GP. This is the formula 1 upon 1 minus r. I have proved that also. I have proved that also. See this. Here, yes. So here I have proved that. Okay. So Sn was this. So infinity. So it was 0. So 1 upon 1 minus r. This was the formula na, what we were having. So r was x. So I have put value 1 upon 1 minus x. So infinite terms of GP 1 upon 1 minus r is the formula. So try to toss everything in your mind. Only then you will get it. So infinity
minus
sum
x.
is I'm going to that only. Very good. So I will simply replace x by minus x in this equation. Are you getting it? So as infinity is 1 upon 1 minus r. So 1 upon 1 minus x we have got it finally. So summation was this. So now I will replace x by minus x here. So what we will get? We will get r is equal to 0 to infinity minus x power r, that is equal to 1 upon 1 plus x. Is it okay?
Yes, sir.
Now what I will say r is equal to 0 to infinity minus 1 power r into x power r. Is it okay? Minus x power r is nothing but minus 1 power r into x power r. See this. ab power x, that is nothing but a into x multiplied by b into x. That is obvious, na? So same thing I have done here. So minus 1 minus x means what? Minus 1 multiplied by x. Minus x is nothing but minus 1 multiplied by x. So minus 1 and x I have just broken it. That is nothing but 1 upon 1 plus x. So now try to visualize this by this. That's why I have written this thing. Okay, so now try to visualize it. What you are getting? AR is minus 1 upon r. So that's what they were asking. If generating function is 1 upon 1 plus x, AR is nothing but your minus 1 power r. Okay. So finally we have got it. AR is minus 1 power r. So now if they want you to give sequence, that is also very easy. When r is 0, but you will say minus 1 power 0 is 1 only. When r is 1, it will be minus 1. When r is 2, it will be 1. Then 3 minus 1, 4, 1. 5 minus 1 and so on up to infinity. So sequence of 1 minus 1 1 minus 1 1 minus 1 and so on like this. So they can ask question like this also. This is the sequence given to you. What is the generating function? So step number 1 will be, first you should write it in numeric function kind of thing. AR will be minus 1 power r. You have to think like this. The moment you get minus 1 power r, so now you will say immediately that sigma r is equal to 0 to infinity minus 1 power r x power r, and I want to find this thing. Okay, so similarly you will say okay, r is equal to 0 to infinity, that is nothing but minus x power r. So now you will say like this, okay, minus x power r we want to find, but I do not know what is minus x power r. I know x power r. So I have replaced x by minus x. So immediately you will get 1 plus x as the answer. Are you getting it? You will find it a little bit difficult for few more minutes, but after that you will get more clarity. Everything is linked. The basic thing is everything is linked here. Just try to focus here.
Got it.
Okay, so take snapshot. If anybody is having any doubt, please let me know. Otherwise, I will jump to the next slide.
The last but one step, sir.
Okay. So how I have written this thing?
That I understood, sir. We just wrote it down because of the sequence. We wrote minus 1 to the power r.
Okay,
And
so generating function, how we will find generating function? R is equal to 0 to infinity AR into x power r. AR is given as minus 1 power r, so that's why I written minus 1 power r x power r. So minus 1 power r x power r is common. So obviously minus 1 will go inside. So minus x power r. So now I will say I do not know what is this sum. I simply know this sum. R is equal to 0 to infinity x power r. That is nothing but 1 upon 1 minus x. And forget about generating function. You simply know by your GP sum also, infinity sum. So 1 upon 1 minus x. So now I simply replace x by minus x. So as soon as I replace x by minus x, r is
One.
equal to 0 to infinity minus x power r 1 upon 1 plus x. So that is your generating function corresponding to this sequence. So the step is very simple. Working rule. If you want me to write working rule is first write step number one. Step number one. First you should write AR. If you write AR, more than 90% work is over. Then step number two is you just have to apply substitutions. Just apply substitutions and get the answer. Don't worry, don't worry. We will solve lots of examples. You will get clarity. You will get crystal clarity of everything. And by the way, this topic is one of the most difficult topic, and many teachers also skip this topic. Okay, just because many teachers do not know how to teach this topic. Okay, this the way which I am teaching, that is the best way. If you are able to grab this, that is more than sufficient. And every time, see from the past.
सर वॉइस नहीं आ रही है.
You're not audible.
Yes, I am audible. I think my internet was gone.
Yes, sir. Now
Yes,
you're
sir.
audible, sir.
Okay, so let me first. I think my screen is also not visible, na?
Green is visible, sir.
No, sir.
Okay, it's visible.
It's visible, but it's not having any movements.
Now I am writing something. Is it visible?
No, sir.
Okay, so that means it's not done yet. Okay, so let me rejoin. Okay.
Yes.
Hmm. Yes. Now I'm writing something. Is it visible?
Yes, sir.
Okay. Yes. So till what point you have listened? Yeah, I was where?
There's a working
I,
rules
I
were
was just
explained.
saying you to take snapshot. Okay. Okay. Yes. So now I will jump to the next slide now. Have you taken that?
Screen share is lost, sir, again.
Again lost. Okay. Let me check. Now, is it visible?
Yes, sir.
Okay, so let me jump to the next slide. Yes, so now next question is generating function is 1 upon 1 minus 2x and we want to find the numeric function AR. So what we should do? So whatever we know, we will simply do it. So what we know sigma r is equal to 0 to infinity x power r, that is 1 upon 1 minus x. Now what you want? 2 we want. So what we will say, x replaced by 2x. So what you will say, r is equal to 0 to infinity 2x power r 1 upon 1 minus 2x. This is what we want. Okay, so what is the numeric function? So now I think it's very obvious, r is equal to 0 to infinity 2 power r into x power r 1 upon 1 minus 2x. So this is the numeric function, 2 power r. So numeric function is 2 power r. They can ask you sequence. Sequence will be what? R is 0. When r is 0, it will be 1, then 2, then 4, then 8, then 16, dot 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 up to infinity. Is it okay? So they can say like this also. They will give you the sequence. From this sequence, they want you to give the generating function for this sequence. So that is very obvious. What we will say. So from the sequence, step number 1 is you will simply write the numeric function. AR is 2 power r. So now you will say, okay, AR is 2 power r. So let me check it out. So I will say, simply you just apply the reverse procedure. What is the reverse procedure? I will say sigma r is equal to 0 to infinity x power r is 1 upon 1 minus x. So now if I replace x by 2x, I want here 2 power r, something like that. I want 2 power r. So how we will get 2 power r? I will replace x by 2x. The moment I replace, I will get 2 power r into x power r. R is equal to 0 to infinity, and here I will get 1 upon 1 minus 2x. So final generating function will be 1 upon 1 minus 2x.
Yes, sir.
Okay, yes. Take snapshot. I will jump to the next slide.
Done, sir.
Okay. Yes. So the next question is generating function is 1 upon 1 minus 5x. Okay, and we want to find the numeric function and the sequence
5
also.
power along
It's very good, very good. So I think everybody has built up the concept here. 1 upon 1 minus 5x. So numeric function will be 5 power r. Okay, and the sequence will be 1, 5, 25, 125, dot 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 up to infinity.
Yes, sir.
Okay, so generalize, I have written here 1 upon 1 minus kx, AR is k power r. So reverse also you should know, when AR is k power r, generative function will be 1 upon 1 minus kx, like this. Both way you should know. Now take snapshot, I will jump to the next slide.
Done.
Okay, let me jump to the next slide. So next is generating function is 1 upon 1 plus 2x. What is AR and what is the sequence? Now can anybody guess? What should be the answer? 1 upon 1 plus 2x?
minus 2 power r.
Yes, very good, very good. So AR will be minus 2 power r. How we have got it? If you have any doubt, let me explain it. Sigma r is equal to 0 to infinity x power r 1 upon 1 minus x. We already know this thing. Now what we want, 1 plus 2x we want. So I will replace x by minus 2x. The moment I replace x by minus 2x, what I will get, r is equal to 0 to infinity minus 2x power r, that is equal to 1 upon 1 plus 2x. So now you simply, I think you have got it. So sigma r is equal to 0 to infinity minus 2 power r into x power r 1 upon 1 plus 2x. So numeric function is minus 1 minus 2 power r. So we have written here only AR is minus 2 power r. Is it okay?
Yes, sir.
Okay, so now I have written some formulas. So if generating function is 1 upon 1 plus kx, so numeric function will be what? Numeric function will be minus k power r. I think you
The
have got it.
sequence
Minus k power r. Yes, please come again.
sequence for the previous ones will be positive and negative, like it's a
Yeah.
exponential.
Sequence. Okay, let me write it. Okay, sorry for that, I forgot the sequence. So sequence will be r is 0, then it will be 1. When r is 1, then minus 2. When r is 2, it will be 4. When r is 3, it will be minus 8, and so on. Okay, then 16, then minus 32, and so on. Odd power minus even power plus.
Yes, sir.
Okay, so generative function is 1 upon 1 plus kx, AR will be minus k power r. When generative function is 1 upon 1 minus kx, numeric function will be k power r. When generative function is k upon 1 minus x, numeric function was k. I think you already know, no? We have studied this few slides back. K upon 1 minus x, AR was k only. So now take snapshot, I will jump to the next slide.
Done, sir.
So now see this generating function and numeric function. 1 upon 1 minus x, it is 1. 1 upon 1 plus x, it is minus 1 power r. 1 upon 1 plus kx, minus k power r. 1 upon minus kx, k power r only. Same thing I have just written again, so that you get more clarity. Okay, and this is very beautiful thing. See this, few more questions are there. So say this, if k upon 1 minus x, you already know it is k. Now please, I think you have got it. K upon 1 plus x, what will be your answer? Minus 1 power r into k. Yes, if you want me to explain, I will explain. Otherwise, I will keep this thing as homework for you. Okay, let me tell you my approach. Okay, I think you have got it, but just for the sake of completion, since it is a recorded session, some of you might watch recording and some of you might get confused. So let me tell you, see this. So generating function is given as k upon 1 plus x, and we want to find the numeric function. So sigma r is equal to 0 to infinity, x power r is 1 upon 1 minus x. Or we know only this thing. From this I will try to derive. So first of all, we want 1 plus x, na? So I will replace x by minus x. So what I will get, sigma r is equal to 0 to infinity minus x power r 1 upon 1 plus x. So now, but generative function was k into 1 upon 1 plus x, but k divided by 1 upon 1 plus x. So I will multiply both LHS and RHS by k. Why? Because they are equal. When they are equal, then we can multiply by k also. So what we will get, sigma r is equal to 0 to infinity k multiplied by minus x power r k upon 1 plus x. It hardly matters actually. See, sigma we have written, so k can be outside, it can be inside, no problem, because it is a constant quantity. We can simply take that common also. I think it's very obvious thing. So next thing will be what I will say, minus 1 minus 1 power r multiplied by k. Sigma r is equal to 0 to infinity x power r, that is equal to k upon 1 plus x. So what is the numeric function? This only. This I have written. Okay, and I think there should be no doubt here, na? K is inside, k is outside. I think that is very obvious.
Yes, sir.
Okay, now please take snapshot. I will jump to the next slide now. Okay, I'm jumping now. Next is
So,
generating function is, yeah.
in previous proofs,
Mm,
minus 1 to the power r into
mm.
k to the power r. So therefore, there
No,
x is
k
missing.
power r is not there.
K into x to the power r you have written as, sir.
Yeah, k into x power r.
Yeah, whereas in the given list we don't have such. It's fine.
No, k. See, this is the numeric function part, na?
Yes, sir.
And it should be multiplied by x power r. Then we will get the generating function value, na?
Right, sir.
Yes. Any doubt?
Done, sir. But it is not needed, not necessary to write it there, sir. K by 1 plus x, where for that numerical function you have given, numeric function you have given minus 1 to the power r into k.
Yes. So here I have written it,
There
na?
we may not- There, in terms of x, we need not to write anything.
Uh, where?
So I think my question is very silly. I
No, no, no
thought
problem. Please ask. No problem. Please ask. Otherwise, you will get confused further. In further questions, you will get confusion. Please let me know what is your doubt.
the route is that simple, sir. Like we have got x to the power r also here in the left hand
Yes.
side.
Okay. So I think you are getting confused. See this. R is equal to 0 to infinity a power r into x power r. That is your generating function. Huh?
Yes, sir.
So we will write this as your numeric function.
Yes, sir.
So
Yes, sir. Yes, sir.
it
That's
should
my
be
own.
multiplied by x power.
I had a very clarity and understanding. I just
Okay. No
slipped.
problem. No problem.
Fine, sir.
No problem.
Thank you so much. Yes, sir.
Okay. So let me jump to the next slide now. See this generating function is k1 upon 1 plus k2x. So what is the numeric function? That is my question now. So if it was, see, we will try to write it very easily. Okay. So if it was 1 upon 1 minus x, then no problem. But now it is plus. So obviously minus 1 power r should be there. Otherwise we will not get it. Now since we have k2, means what? K2 power r will be there. And because of k1, I will simply multiply it by k1. So indirectly, I will say finally we will get minus k2 power r into k1. This is my answer. Yes, any doubt? Let me solve it. If you have doubt, let me solve it. So
Understood,
see
sir.
this. Okay. Yes.
Clear,
If
sir. Clear.
clear. Okay, then it's fine now. What about this scenario? So I will say here we have k2. So I will simply write k2 power r. Because of minus, no problem. Now multiplied by k1. So simple. So now here 2. So simply I will write 2 power r. Because of 5, I will multiply it by 5. Because of 6 here,
Minus
and because of plus here, minus 6 power r multiplied by 10 because of this. Is it fine?
Yes, sir.
Yes, sir.
Okay, so see this, so much speed we have built up. Okay, so these are the just building blocks. If you know the building blocks, immediately you will be able to answer question in GATE exam. They will directly ask, this is the generating function, what is the numeric function? That's it. Or this is the numeric function, what is the generating function? That's it. Okay, let me and see the reverse process also. Multiplied by 10, so obviously 10 upon 1 minus x will be there. Now minus 6 power r, so obviously plus 6. That's it. This is my answer. This was there only. And here I will say 1 upon 1 minus x, 5. So I will write here 5. Okay, 2 power r, so simply 2. That's it. Okay. So let me jump to the next slide. So now see this 1 upon a minus x. What is the numeric function? Now if you have done integration and all, you will be able to answer this question very easily. You have to do very small manipulations and you will get the answer. Please let me know.
इसे मल्टीप्लाई डिवाइड कर देंगे सर और उसके बाद
Very good then.
उसके बाद वन बाय ए का जो है डिफरेंस आएगा मतलब कॉमन डिफरेंस आएगा तो 1 बाय ए पावर आर ए
हाँ.
इंटू 1 बाय ए पावर आर शायद.
Okay, so see this. We will divide this by a, and I will take a upside. So 1 by a. So we will divide both up and down, numerator and denominator by a. So 1 upon 1 my x by a. We will get this thing. Are you getting it?
Yes, sir.
Multiply numerator, because here a is creating problem for us. Nah, we want 1 here, and here we are having a. So simply just replace this a. So how we will get 1 here? So numerator denominator by a we will divide. So 1 by 8 upon 1 minus x by a. Now please see this, 1 by a 1 minus 1 by a multiplied by x. Now please tell me the answer. What will be our answer?
1 by a into 1 by a power r.
Yes, that's it. 1 by a into 1 by a power r. So that is nothing but 1 upon a power r plus 1. So simple. Is it okay now?
Yes, sir.
So I think you might have got the feeling of integration. That was the basic linking which I want to do. 1 upon a plus x. So what we will do again, 1 by a, 1 plus 1 by a multiplied by x. So what we will do now, minus 1 by a power r multiplied by 1 by a. Yes, please let me know if any doubt.
No, sir.
Okay, so if you have no doubt, then please tell me first of all this. Then we will study this. What should be done here?
K1 by K2 into
K2, yes,
K3 by
upon
K2.
1 K3 by K2 x. So what will be our answer? K3 by K2 power r multiplied by K1 by K2. Is it okay?
Yes, sir.
Yes, sir.
What about this? Now
माइनस
I
साइन आ
think it's very
जाएगा.
easy. Yes,
हाँ,
yes,
sir.
that's it. So minus K3 by K2 power r multiplied by K1 by K2. Yes. Please take snapshot. I will jump to the next slide now.
Yes, sir.
Okay. So next is 5 upon 5 minus 3x. What is this is the generating function given. We want to find numeric function, x power 20 coefficient, a15 and the sequence.
3/5 पावर आ रहेगा जनरेटिंग फंक्शन.
3 by see, this is the generating function given. We want to find numeric function. Numeric
Yes, sir.
function will
न्यूमेरिक
be
फंक्शन
3 by
3/5
5 power r multiplied by 5. Okay, no need to do multiply by 5 because if yes, we will divide by 5, so we will get this only. Yes, good. AR is 3 by 5 power r. What about x power 20 coefficient? 3 by 5 power 20. What is A15? 3 by 5 power 15. Yes, x power 20 coefficient is the problem.
No, sir. I answered the 3 by 5 by 5 power 15.
So I should write like this: coefficient of x power 20. Coefficient of x power 20 in power series expansion. In power series expansion. So it is nothing but same as your A20. A20 into x power 20 will be there. So A20 is 3 by 5 power 20. A15 is 3 by 5 power 15. So what is the sequence? Sequence will be 1, 3 by 5 power 1, then 3 by 5 power 2, 3 by 5 power 3, dot dot dot. Is it okay?
Yes, sir.
Now please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So next is 3 upon 1 minus 5x. What is the numeric function? This is the generating function. Okay, terminology should be very crystal clear to you. This is the generating function. X is there now. As soon as you find x, it is generating function only. Because generating function is function of x. Ax we have written. Ax. Function of x only. Generating function is function of x. Ax. Okay, so this is generating function given to us, and more precisely what is this? This is the closed form of generating function. Closed form. What will be the open form? So you have to find like sigma, and then we will find it. Don't worry, I will find open form also. And open form is nothing but your by the way your sequence type thing only. Okay, so what is the AR? What is the numeric function?
5 by 3 to
3
the
into
power
5
r, sir.
power. 3 into 5
5
power.
5
by
by 3.
3
okay,
into
okay.
5 power r.
So 5 power r multiplied by 3. Yes. So this is our numeric function. Because here there was 1, so no problem at all. Okay, and if we want open form, so I will write like this. So sigma r is equal to 0 to infinity 5 power r into 3 into x power r. This summation I have found out to be 1 upon 1 minus 5x. Please try to focus here. R is equal to 0 to infinity 5 power r into 3 into x power r. This summation, entire summation value is 3 upon 1 minus 5x. That is what generating function is saying. Okay, and if you want it open form, then obviously it will be a kind of tedious task. So I will write 5 power 0 into 3 into x power 0 plus 5 power 1 into 3 into x power 1 plus 5 power 2 into 3 into x power 2 dot 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 up to infinity. So this is the sequence. This is the open form of generating function. Open form. I have told you, no, open form means you just open it up. That's it. Okay, this is the open form. And this is the closed form. So in GATE exam, normally you will find closed form only because obviously it is very tedious. It is difficult to write and all these things. So they will use simply this type of thing. Okay, so 3 upon 1 minus 5x. So finally numeric function is coming to be 5 power r into 3. And by the way, they can give this series also, and they will say up to infinity what is the sum of the series. So you may get confused in GATE exam. So you will immediately say, see, this is the beauty. They will say up to infinity. The moment they say up to infinity, you will say, okay, the question is of generating function. By hook or by crook, try to give it the form of your generating function. You will get the answer. Okay, from here you will write, you will go here, and the moment you come here, that means from here you just write the closed form. The moment you come here, you will get the answer as this. That is very obvious. Okay.
Yes, sir.
Yes, sir.
Okay. So next is 5 upon 1 plus 6x. So that is also very easy. So what will be our answer? Minus 6 power r multiplied by 5. Here 7 power r multiplied by 6.
Yes, sir.
So here
6
what
by
should be the
7
answer?
into 2 by 7 power, minus 2 by 7 power.
Yes, minus 2 by 7 power r. Let me write it properly. Yes. Please take snapshot. I will jump to the next slide now. Done?
Yes, sir.
Okay. So the next, so now we will study the property. So when AR is the numeric function, AX is the generating function. This is the numeric function. This is the generating function. So when numeric function is multiplied by k, that was the first property which we have studied. So the generating function was also multiplied by k only. That means k into a power ax. So now the next property which we have done so far, but I want to generalize it. When ax is it is the reverse. Second property, the reverse of the first. When ax is the generating function, then ar is the numeric function. So when this x is replaced by kx, the corresponding numeric function is multiplied by k power r. Are you getting it? That is the beauty. So ax, then numeric function is ar. When x is replaced by kx, then ar is replaced by k power r multiplied by ar, and we have done it just now. So simply now application of this property, I will say like this: 1 upon 1 minus x is 1, 1 upon 1 minus 2x. So x is multiplied by 2, or you can say x is replaced by 2x. Here x is replaced by 2x. So obviously numeric function will be multiplied by 2 power r. So I will write like this. So here x is multiplied by 3. So obviously numeric function will be multiplied by 3 power r. Just now we have done these things. Any doubt?
No, sir.
Okay, so let me jump to the next slide. So generating function is 1 upon 1 minus x. Numeric function is 1. We already know. Now question is 1 upon 1 minus x square. If generating function is 1 upon 1 minus x square, what will be the numeric function? We want to find this thing. So approach will be similar. Approach is similar only. The approach which we have done till now. So what is this? We already know only one thing. We know only one thing. What is that? R is equal to 0 to infinity. X power r, that is 1 upon 1 minus x. We want 1 minus x square. So what we have to do? Replace x by x square. So what we will get? R is equal to 0 to infinity x square power r, that is 1 upon 1 minus x square. By the way, why I am able to replace x by x square? Because both these are equal. These are equal. And one more thing I want to say, as many students do this kind of confusion. They will say 1 is equal to 1 upon 1 minus x, because this is the numeric function, this is the generating function. Can I do like this? No, this is not the case. Why? Because they are not equal. I will say AR multiplied by x power r, and r is equal to 0 to infinity. Then that will be equal to the generating function. That is equal to 1 upon 1 minus x. Are you getting it? These are the very few tips and tricks which many students get confused. Now do not say AR or generating function, they are equal. No. Who is saying they are equal? They are not equal. Equal is what? Equal is what? AR multiplied by x power r, that is equal to 1 upon 1 minus x. Okay, so generating function, this is GF, closed form. So generating function is AR into x power r is equal to 0 to infinity. Then we will get generating function. Okay, so see, so now here, see this, I am not saying 1 is equal to 1 upon 1 minus x. See this, I am not saying like this. I am saying r is equal to 0 to infinity x power r. 1 multiplied, you can do 1 multiplied we can do. So 1 multiplied by x power, that is 1 upon 1 minus x. So now I have replaced x by x square, we have got this thing. So now we will simply, what we will say, r is equal to 0 to infinity x power 2r, that is 1 upon 1 minus x square. So now question arises, what will be our numeric function? What should be our numeric function now? So you will say, sir, you simply say x power r multiplied by x power r. Many of you will say like this, 0 to infinity x power r multiplied by x power r. That is nothing but x power 2r. That is 1 upon 1 minus x square. So numeric function is x power r. No. Numeric function is not function of x. Please try to follow. Numeric function is not function of x. Only generating function is function of x. So this is numeric function? No, you cannot say like this. This is numeric function. No. Why this is not numeric function? Because only generating function ax, that is function of x. Function of x. Numeric function is not the function of x. Numeric function is not function of x. So now question arises, how to find that value? Okay, how to find the numeric function? So now I will apply a small trick. What I will say, I will simply try to expand it. What I will get? What I will get? So I will say when r is 0, I will get x power 0. Then when r is 1, let me write it. When r is 1, I will get x square. When r is 2, I will get x power 4. X power 6, x power 8, dot dot dot, up to infinity. So now when we expand this thing, r is equal to 0 to infinity, sigma r is equal to 0 to infinity, ar into x power r. What was the expansion? So a0 into x power 0, a1 into x power 1, a2 into x power 2. This is the beauty of mathematics. Try to link the things. Linking is mathematics only. A power 3, a4 into x power 4, dot dot dot. So now try to link this with this. What you have got? A power 0 into x power 0. X power 0 we have got it. So a power 0 is nothing but 1 only. So I will say like this, 1 multiplied by this. So now x power 1 into a1. So a1 should be 0, na? That's why I have not got here x power 1 term. So I will say a0 is 1, a1 is 0. I am just comparing. a2 into x power 2, and we have got here x power 2 only. So a2 is 1, a3 is 0, a4 is 1, dot dot dot, like this. So now we have got the numeric function. So what is the numeric function? 1 0 1 0 1 0 1 0 and so on, alternating. So let me write it. So sequence, let me write first the sequence will be 1 0 1 0 1 0 1 0 dot 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 up to infinity. So now if I want to generalize, what I will say, AR is equal to 1 if R is odd, that is, and broken function we will get 0 if R is, oh sorry, R is even, na? This is not 1 2 3, this is from 0 we are counting, na? Whole number, A 0 is this, na? So from 0 we are taking. So when R is, this is A 0, na? So when R is even, 0 when R is odd. So that is the numeric function. Any doubt?
No, sir.
No, sir.
Okay, so you might feel difficulty in only two, three questions, and then I will make you so much comfortable in that you will be able to answer these type of question also very fluently. Okay, don't
Yes.
worry about that. Okay, so we have got it. So now let me jump to the next slide. Okay, only 2-3 minutes are left with us. So I just want to clear few more things. Okay, so just bear with me for only 2-3 minutes. Let me jump to the next slide now. So finally, generating function is 1 upon 1 minus x square. I have told you 1 upon 1 minus x square. The moment you get it is the generating function only, ax, function of x. What is a200? I have just told you, when even it is 1. It is also even 1. It is odd 0. It is coefficient of x power 120 we want. That is nothing but a120. Even 1. It will be 0. That's it. So simple. Yeah, they can ask question like this. Is it okay? So how we have find it out? So what was the way? Just to revise. What was the way? The way was very simple. I simply replaced x by x square. Standard was this only. I simply replaced x by x square. But the problem was that we got x power 2r. Now I do not know how to expand it. How to find the value of numeric function. So I simply compare it with the standard way. AR into x power r. And from that I have got the value that AR should be 1 when r is even. It should be 0 when r is odd. That's it. Okay. Yes, so that's it. So this is all for today. So in the next class we will resume this generating function part only. Okay then.
सर
Yes.
सर प्रोपोजिशन लॉजिक का एक डाउट था मेरे को.
हाँ बोलो.
सर वो एक डाउट मैंने ग्रुप में सेंड किया था. गेट 2015 से मतलब रिलेटेड क्वेश्चन था, तो उसको मॉडिफाई किया मैंने थोड़ा सा. सर अगर हम कोई चीज कंक्लूड, सपोज कोई चीज स्टेटमेंट्स दी है उसको ट्रू मानते हैं किसी लॉजिक से, और उसके करस्पॉन्डिंग जो है इम्प्लीकेशन वाला इक्वेशन लिख देते हैं, तो सर उसके बाद उस इक्वेशन का इनवर्स लेंगे तो क्या इनवर्स भी ट्रू होगा? मतलब इनवर्स क्या हम कंक्लूड कर सकते हैं आंसर में?
You want to say कि P implies Q को आप true मान रहे हो.
Yes sir.
And you want to conclude inverse is true like this.
Yes sir. Yes sir.
So directly indirectly see this. So your problem boils down to this thing. P implies Q implies not P implies not Q. This should comes to be a tautology. If you are able to prove that this is a tautology, then your work is over. Otherwise,
in general sir ये काम करेगा या नहीं करेगा?
So we have to check na whether it is tautology or not. We have to check. So we can check it out. Okay. So P implies Q implies not P implies not Q. So in order, if you want to prove it tautology, so you just try to prove this as true and this as false. If you are able to prove this is true, this is false, you will say this is not a tautology, and you won't be able to conclude that thing. So this is true, this is false. So which is easy? Making this true is difficult because you have to consider 3 possibility. This is very easy because considering false is very easy now. So what we will say, so you consider this as true and this as false. So not P is true, that means what? P is False.
Yes, sir.
Okay, and not Q is false, so that means Q is
Yes,
true.
true.
So you just put it here. P is false,
This will come true.
and this is true. So false
Yes,
implies true is true. Obviously, this is true.
implies false.
So we are able to make this as true and this is false. So this is not a tautology.
It
So
is
if
not a tautology.
implication is true, then inverse, I cannot conclude inverse is true.
Okay, sir. Contrapositive
Okay.
we can conclude. Contrapositive.
And I have told you this thing also. Now P implies Q. We have four things. Not Q. P implies not Q. Okay, and Q implies P, and not Q implies not P. These and these are equivalent.
Yes, sir.
These two are also equivalent.
Yes, sir.
So when this is true, I cannot say this is true or not.
Okay, sir. Got it.
Okay.
Yes, sir.
Four questions. Now try to remember. I have told many times. Four questions we have. So when this is true, this is also true. This is for sure. But for these two, I cannot say. I cannot guarantee. Okay then. So let's leave the class here itself. So from here we will start the next class. Okay then. Bye
Thank
bye.
you.